Welcome to today's webinar titled Developing a Utility Water Management Program to Optimize Costs, Improve Safety, and Reduce Water, Chemical, and Energy Usage. My name's Billy Zadig, Manager Special Programs for APA. Just a couple of housekeeping items before we get started. The webinar recording will be posted to the APA website later this afternoon. Please visit our website at www.apa.org to register for upcoming events and to view archived webinars for continuing education credits found under the Continuous Learning tab. APA-U is back live in person and coming to Providence, Rhode Island in September and Fort Worth, Texas in January 2023. Information is available on the website under CLS tab. Professional continuing education credits are being offered for today's program. AIA members who need their attendance reported to AIA should contact me at Billy, B-I-L-L-I-E, at apa.org. Those who indicated they wanted a certificate at registration and meet the requirements will receive certificates later this afternoon. All attendees are in listen-only mode. Please type your questions in the chat box and they will be answered in the order they are received. If we run out of time and we still have questions, responses will be sent directly to the person asking the question by our presenters. If you're just calling in, make sure to send me an email at billy@apa.org so I can send you a certificate if you would like one. The system only recognizes you if you log in. At this time, it's my pleasure to turn this over to Mike Doyle and Rick Dandaro. Mike, take it away.
Okay, Billy, I think Rick's locked up again. Are you able to change slides, Rick?
I cannot, Mike. It's locked again. My apologies.
All right, Mike, I'm going to make you the presenter so you can, if you're ready, I'll just switch you over.
Okay. Can you see that?
Yes, Mike.
Okay. So here's a few things we were showing you, or should have been showing you while Billy was talking there. There's a description of the webinar, what we're going to go through today. Our learning objectives. My slides are changing okay, aren't they, Billy?
They are, Mike.
Okay. And so here we are. So welcome, everyone. Thanks for joining us today. Sorry for the hiccup. Our presentation today, as Bobby said, is developing a utility water management program to optimize costs, improve safety, and reduce water, chemical, and energy usage. Now that's a mouthful and we have a lot to cover, so let's get going. Here's our agenda. After introductions, we will have a quiz, but there'll be no studying required. Next, we will walk or talk through some efficiency opportunities. Then we'll get to the how-to part of the presentation, followed by 2 case studies. Lastly, we will wrap it up with a summary of what we have covered, with plenty of time for you to ask questions. And to set expectations and your coffee runs and everything else, we should make it to the Q&A portion of the program in about 30 minutes or so. So you won't be here for an hour. So a little bit more about me. My first career was in facilities and construction management for the Navy, including 2 tours as a public works officer. One at the Naval Station Rota, Spain, and the other at the Naval Academy in Annapolis, Maryland. After my transition from the Navy, I worked for a general contractor managing large military construction projects for about 2 years. But my real second career for the last 12 years has been with Vigenix, helping facility owners manage their building water systems safely and cost efficiently, with an emphasis on higher education facilities. I currently live in North Carolina, but I travel the country working with clients and our field personnel. Also with me today is Rick Dandaro. He has tons of experience in property operations and facilities management around the country. He has been with Vigenix a long time and is our go-to expert when it comes to utility water management. Today, Rick lives in Florida and supports our field engineers and clients across the country. And a little known fact about me and Rick is that we were both Phygenics clients at one time before we came to work for the company. And just so you know who Phygenics is, we help facility managers optimize the total cost of their water systems by improving safety and efficiency. Building and operating water management programs is all we do all day, every day. We like to start our presentations by explaining our bias. Although many of us don't think about it, every speaker or presentation has a bias of some sort. We like to put ours on the table so that you can judge and evaluate where we are coming from. Phygenics chooses to be independent from profiting on the sale of water treatment products and services. Our only bias is to work with facility owners and managers to achieve defensible, data-driven water management programs which verify and validate that their building water systems are safe, efficient, and cost-effective. So, enough about us. Let's get started. These questions here are just to get you thinking. If you are interested enough to attend this webinar, you probably know the answers to some of these questions. But in most cases, it'll be more than just one person on the campus. Are all of those persons on your water management team? Do you even have a water management team? Operating the utilities on a campus is expensive and is getting more so every day. We're going to talk about the many ways to influence these costs, as well as improve the quality of service while achieving your desired outcomes. So in order that I don't lose you early in the presentation here, I'm going to jump right to the punchline, and then I'm going to go back to tell you how to get there. So what does a utility water management program do for you? With numbers as big as we were talking about, even slight improvements can make a big difference. We have seen these kind of improvements on both large and small campuses alike. And we just quizzed you on the cost of heating, cooling, treating, purchase, and disposal of water, which is huge. It only makes sense that there would be significant opportunities to save costs in these areas. These savings opportunities are not always present in all facilities, but there are very few facilities where we find zero savings. So jumping right in, let's talk about cycles of concentration. It never gets old. And why do I say that? It's because no matter how much we talk about it, we always run into facilities that have not optimized it. As you know, cycles of concentration is, in other words, how many times water flows around the cooling tower loop before it is dumped to waste. You want to optimize the use of the water while taking into consideration the cost of the water, sewer, chemicals, energy, and service hours, while ensuring that you're not jeopardizing the lifespan of the equipment. We see far too many systems where facilities are spending 2 to 3 times as much as they should be on cooling tower operations. So how much should it cost to treat cooling water? Well, as they say, that depends. What is surprising is the consistency of the benchmark in a well-managed, cost-optimized program across a region. The key is, do you know your numbers and have you benchmarked them? And remember, a cooling tower is a cooling tower. If you have a campus plant the same size as the hospital complex down the street, your benchmark should be similar. You want to add up the costs for all chemicals, all testing, all equipment related to feeding the chemicals, and then all service divided by your gallons of makeup water times 1,000. So for 10 million gallons of makeup water and a total cost of $20,000, your benchmark cost is $2 per 1,000 gallons. So the question is, have you benchmarked your system, and how does it compare to your regional neighbors? There are many questions you can ask your staff and water treatment supplier. Do you really need a proprietary oxidant, or will a generic product work just fine? How are you feeding your chemicals? Is it slug fed, timer, etc.? Do you validate or measure their performance? Periodically running through these questions is a good management practice. So now we're going to shift to the other side of the heat transfer process of a cooling system. Why is chiller efficiency important? Well, did you know that centrifugal water chillers can account for 20 to 40% of a facility's total energy consumption, or that it can lose 30% efficiency and appear to be operating satisfactorily? This is an example of a typical chiller plant in a large building or small campus complex. The assumptions are that the plant is running at an efficiency of 65 kilowatts per ton, that the cost of electricity is 8 cents per kilowatt. If you're still getting that nowadays, it's a lot higher in other parts of the country, and that the equivalent full load cooling hours is 3,000. EFLH is the number of hours a chiller system would have to operate at full load to achieve or equal the amount of cooling delivered by the system at a constant temperature over an entire cooling season. So it's essentially how long you're running at full load in the course of a year. And as you can see, with those simple numbers and a 15% efficiency applied, $234,000 is a lot of money in anyone's budget. So even with brand new chillers that collect reams of continuous data that is recorded somewhere in your building automation system or the chiller itself, you still find facilities maintenance personnel recording some of it on a clipboard. In addition, every chiller has alerts or alarms to warn you of serious problems, and everyone performs periodic maintenance. But in the majority of facilities we see, there is no analysis of all the data collected, no matter how it's collected, that shows you where you are on the continuum between operating your chillers at design efficiency or operating your chillers at the ragged edge of efficiency or even failure. And again, your chiller can be running fine and still be 10%, 15% inefficient, or it could be providing cooling. So some takeaways. Chillers are expensive to operate and small losses in efficiency add up fast. Everyone has data, and in most cases, probably too much data. The question is, what are you doing with it? And so if you analyze the data regularly, then use that data to identify problems, and then you identify what the solutions to those problems are, and then you have to calculate an ROI, because there are times when the cost of the solution does not make up the difference in energy lost, and it may be way better to put that repair off. But you need to do this in order to make informed decisions. And then, of course, you have to implement those decisions and restore the efficiency back to design levels. So at the end of the day, I mean, do you, if you're responsible for chillers, know the operating efficiency of your chillers? And that's more than just the approach temperature. So let's shift from cooling systems to heating systems. Just like with your cooling towers, you need to know how many cycles of concentration you are running in your boilers. It depends on several factors, but 50 cycles should be achievable without jeopardizing your capital equipment, even in small boilers. And just like with the cooling tower checklist, there are many questions you can ask your staff and water treatment supplier. Do you monitor, track, and trend your water chemistry parameters? Have you looked closely at your injection points? How do you pre-treat your water? The answers to all these questions can have a large impact on cost optimization and performance of your boiler systems. Well, if the words on this slide look a lot like the "how much should it cost to treat a cooling tower" slide, then you've been paying attention. The benchmark numbers in a well-managed, cost-optimized steam system are also surprisingly consistent across the region. But do you know what your benchmark numbers are? In order to calculate them, you want to add up the cost for all chemicals, testing, equipment, and service, divided by the number of pounds of steam your boiler produces per hour. So for a 10,000 pound per hour boiler and a total cost of $15,000, your benchmark cost is $1.50 per pound per hour. There are sometimes reasons it can be well above or below, but you want to understand what they are and if those reasons are justified. So here's another example. You can do this at home. Here's a quick example of the impact of increasing your cycles of concentration in a steam boiler up from 10. 10 cycles may seem low, but it is more typical than you would think. We come across it all the time. In many situations, you can raise the cycles of concentration to 50. Doing so results in savings of over $47,000 from just one boiler. Multiply that by several boilers or double the number of the size of the boiler, and pretty soon you're talking about some pretty serious cost savings without jeopardizing your equipment. And again, we never want to take you to the ragged edge of efficiency in any of these examples. You want a margin of error. So now we're going to jump from what the efficiency opportunities are to how to put together a program to achieve them. ASHRAE Standard 188 has a 7-step process for developing a safety water management program. We, of course, are talking about efficiency, not safety. But the analytical process is scientifically solid and adapts well to identifying, controlling, and managing water systems to achieve efficiency goals. Let me show you how. The first step is the most important. You need to form a team that has both the responsibility and authority to act. It needs to include all of the water stakeholders, not just the in-house utility department personnel. So you also need the input and expertise of your water treatment provider, your maintenance service vendors, and we, of course, recommend a third-party expert to facilitate the process, to document progress, and to keep everyone on the same page. Because without clearly defining responsibilities, there are either gaps or overlaps between parties, which in turn creates conflicts about who is doing what. And then we all know who's left holding the bag. So clearly defining roles, responsibilities, and authority around shared and common goals, which we'll talk about shortly, is instrumental in the success of your program. A performance-based water management program first facilitates a team approach to identifying and solving problems. This clears the way towards achieving your goals, which is what ultimately everyone wants, but which sometimes gets lost in the fog of everyone's individual duties and responsibilities. I don't think there's anyone on this webinar that doesn't agree that you need goals. I'm reminded of another way to say that you need goals is with the statement, if you don't know where you are going, you might wind up someplace else. And if you're old enough to know who said that without Googling it first, please reply with your answer. There's no prize, but we will announce your name at the end of the webinar, your first name at the end of the webinar, at which time you will be rewarded with the respect and admiration of all those in attendance today. Goals, KPIs, metrics, whatever you want to call them. Without them, as we said in the previous slide, you might wind up someplace else. And it may be someplace you don't want to be, like in front of your boss explaining why your chiller, boiler, or cooling tower only made it halfway through its useful life. So these 5 KPIs here are the broad categories that we use to define where you want to go. There are just 2 or 3 very specific SMART sub-goals under each of these. And if you've not heard the term before, SMART stands for specific, measurable, achievable, relevant, and time-bound. If you have too many poorly defined goals, you will eventually get lost in the data and wind up someplace else. The next step is describing your water systems. You must describe your water systems from a process point of view. This is not a detailed mechanical drawing, but it must be correct and contain enough detail on the critical points in your utility water processing where you can affect the outcome. Then we get into analyzing water systems for, you can see the little slides that safety and efficiency. What we're going to be talking about right now, in the case of a utility water management program, we are focused almost entirely on efficiency. But as we mentioned above, the process is the same. This is a step where you analyze the critical points in your utility water processes and decide whether or not it is worth the time to collect and analyze the data to affect and achieve your efficiency opportunities. This is an important step that requires knowledge of water treatment and water management. You need to know where to look. We focus on operational changes that result in immediate cost savings without jeopardizing the performance of your capital assets. You do not need to develop large capital improvement projects with lengthy return on investment times. An evaluation of your expenditures often turns up significant opportunities to optimize costs. These were the opportunities that we talked about earlier in the brief. These are the measurements and monitoring that your operators and vendors are going to document, as well as, and this is key, what they are going to do to correct any situations where the system is not operating within the limits you have set. This is where the rubber meets the road. It is the how you are going to achieve your goals. Some or all of these measures could be part of an effective water management program. By effectively managing these measures, you are optimizing costs and efficiencies. However, you can't monitor everything. You don't want to monitor points in the process that have little or no impact on your program. If the program is not running as designed, you will never be able to figure out why, because you are overwhelmed with data. Having systems that are running at suboptimal levels is like leaving the windows in your house open when you have the heat or the AC running. So how are you going to show that you are doing what you said you were going to do? Well, think about a scientific experiment. These are the operational boundaries or constraints. And like in an experiment, if you don't stay within the boundaries, then the results are not going to be valid. Or in our case, the desired, repeatable, and consistent results are not going to be achieved. Verification is a quality assurance function. It is the confirmation that the utility water management program has been implemented as designed. Using service reports, PM records, and such, you can defensively prove with documentation that your program is running the way you intended it to run. And you demonstrate that when it gets out of whack, which is a highly technical facilities management term that I used to use, you take quick action to get it back on track. Lastly, everyone wants to be able to show their boss that they can achieve their goals, KPIs, targets, metrics, again, whatever you want to call them, as we discussed in step number 2. This is how you do that. Validation is a quality control function. Validation is confirmation that the utility water management program is effective when implemented as designed, and that you are reaching the goals you set out to achieve. In a well-designed utility water management program, the measures and metrics that come with regular validation will inform your operational decisions. And equally important, a well-designed program includes validation responses. What actions are you going to take if you are not achieving your goals? An effective water management program requires active oversight and management. Here are some examples of program validation for a utility water management program. You should be able to sum up the results of your efforts and your program on a single page with a half a dozen or so pieces of information. This is the last step in the water management program process. It is an endless loop. You operate the program, and then you analyze, control, verify, and validate. So next, we're going to get to a couple of real-life examples. This is an example of a client with geographically dispersed buildings and campuses who wanted consistent service and consistent performance with a simple set of KPIs to measure water performance across the enterprise. They did not realize the economies of scale and the services that many water treatment companies will offer or include at little or no cost. They now receive a service report tailored to their enterprise requirements, which will not change if they change vendors, and KPIs that are much easier to track, trend, and manage at significant cost savings. And from one of your own, the University of Minnesota has a huge campus with over 60 open cooling systems and over 300 closed loops. With this many systems and with all the university maintenance and utility personnel, mechanical vendors, water treatment vendors, and building personnel, as the quote implies from Scott, this was as much a management problem as anything else. A concise water management program with accountability and responsibility clearly assigned to the appropriate team members that then focus on the right controls and the right KPIs is essential. Done correctly, in this case over the past 12 years, the results speak for themselves. So I told you I was going to get you here quick. To summarize, a utility water management program is an insurance program for your capital equipment and a roadmap to optimizing your cost. Just follow the process. Create your program, operate it, verify that you are running it the way you designed it, and then validate that you are achieving the desired results. Then reevaluate and adjust as necessary on a regular basis. The process works. Lastly, don't develop a plan you can't execute. Analytical folks, like many of you on this webinar, like precision and lots of data. So be careful. What you really need are simple controls or guardrails that keep you on track, and KPIs or goals that are achievable at your facility, with your staffing, with your vendors, and with your resources. Thank you for your time. That wraps it up, and we now have time for some questions. Rick, are you on the line? Have you been able to pick up any questions?
Mike, I am on the line, and no questions as of yet, other than possibly someone looking for clarification on the rule of thumb or general guideline on cost of boiler operations for 10,000 pounds produced per hour. And I don't know if there was confusion, but that price of $1.50 is just a rough number based on 10,000 pounds per hour produced, but that is an annual cost. So that would be roughly around $15,000 for the year as an example. But I will clarify to the team that if you indeed were questioning that, there's a couple other variables that come into play when you're talking about boiler efficiency. And of course, load has a tremendous impact on the efficiency of your boiler. And then you also have a combustion rate efficiency. So these are general numbers that we've been talking about, or Mike's been presenting to you, that are just some easy measurements to consider. But there's definitely more that you have to take into account in your operations and learn about your operations to really make a great comparison.
Okay. Here's something I picked up, not sure where. The question is, in your cooling tower example, you come up with a benchmark of $2 per 1,000 gallons of makeup water. I did some quick calculations and I think my benchmark is closer to $5. Is that a good number? And I guess, well, we always say that it depends, sort of like Rick was saying there. First, what's the quality of your makeup water? That depends on what part of the country you're in. And actually, up until last year, we used to say that $1 to $1.50 per 1,000 gallons of makeup water, was a good number if you're using a water treater in a large plant. If you're just buying bulk chemicals and treating the towers yourself, it was less than $1. And of course, it also depends on the level of service you want. Is your water treater there once a month or once a week? What is he doing while he's there? But of course, now with higher inflation, those numbers are going up. We're starting to see that already. And that said, without knowing more, $5 does seem a little bit high, but there are times where, we found those kind of numbers were justified. And I've got one other question that came in here. Rick, I don't know if you've got any. Let's see. We gauge whether or not our chillers are running efficiently by our approach temperatures. We try to keep them below 5 degrees. Is that a good way to do it? Is 5 degrees good, I guess is what the question is here. And that is a good question. And for background for everyone, the approach temperature on a chiller is the temperature difference between the incoming refrigerant and the outgoing condenser water. It's a measure of the heat transfer efficiency of the chiller, and it's one of the main ways, but not the only way, to gauge the overall efficiency of your chiller system. But back to your question, in most cases, i.e. it depends, your target should be 2 degrees or less. For every degree above that, you lose roughly 2% efficiency. So if you're at 5 degrees and you say your target's 2, 5 minus 2 is 3, so you have an excess approach of 3 degrees. So 2% times 3 degrees, you're losing 6% in efficiency, which, if you remember the numbers in the example, adds up quick. But also note that there's many other reasons for a chiller to lose efficiency that aren't really captured by measuring the approach temperature. They're not hard to calculate, but it is a matter of capturing the right data and crunching the numbers. Let's see. I think that's all I can see on my end. Rick, anything else come in?
No, Mike, no other questions. Let's not forget about your quote of the day before we conclude.
Oh, that's right. I almost did forget about that. So if you forgot the quote I said earlier in the presentation, if you don't know where you're going, you might wind up someplace else. And I don't know, did anybody send in their name, Rick?
Mike, we did get a couple of responses. I did not know who that was, and I did not Google. So I'll ask you the question: was it Yogi Berra?
Yes, it was. And so who gets our,
If that's the case, James Moeller was the first to respond.
all right,
Hopefully I
congratulations.
got the last name correct.
I won't ask you how old you are. If you're a young guy, congratulations for keeping up with history. But yeah, Yogi Berra had a lot of yogiisms, they call them. And I don't know if he did it intentionally, or there's some people speculate he actually had a problem with speech. But anyway, if you don't know where you're going, you might wind up someplace else. And a utility water management program will hopefully help you figure out where you're going. Get the right folks together, pull together your team, come up with some goals, and work towards getting there. And with that, I think we will wrap it up. Billy, back to you.
Okay, well, thanks, Mike, Rick. You got your information there, so I know people will be reaching out to you. Thank you for a very informative webinar today. And as always, to our attendees, thank you for taking time out of your busy schedule to be with us. So until next time, be safe, stay healthy, and be kind to one another. Thank you so much. Bye-bye.
Thank you.